Imagine a world without computers, without smartphones, without space science, without global trade as we know it. All of this exists because of a single revolutionary idea, zero. And this incredible concept was first formalized in ancient India, over 1,500 years ago, by the great mathematician Aryabhata. Today we uncover the story of Aryabata Zero, and how this mathematical revolution changed the course of human history forever. Before zero, mathematics was a struggle. The Romans used numerals like I, V, X, L, and C, but try multiplying with them, and you'll see the nightmare. The Egyptians and Babylonians had clever systems, but none had the true concept of zero as a number with its own value. Without zero, calculations were slow, trade was limited, and advanced science was almost impossible. Humanity was stuck with clumsy mathematics. As the Western Roman Empire was crumbling, a golden age of discovery was dawning in India. In this vibrant intellectual landscape, in the year 476 CE, a genius was born, Aryabhata. He emerged from an era of unprecedented progress in science, art, and philosophy, a time when great universities like Nalanda attracted the brightest minds from across the continent. It was in this environment that Aryabhata's revolutionary ideas would take root and flourish. At the astonishingly young age of just 23, he composed his masterwork, the Aryabhatiya. This wasn't a sprawling encyclopedia, but a concise and elegant treatise of only 121 verses, written entirely in Sanskrit poetry. This poetic structure made it easy for scholars to memorize and transmit, ensuring its survival and influence for centuries. The text was a distillation of the most advanced mathematical and astronomical knowledge of his time, a comprehensive system for understanding the cosmos. Within its verses, Aryabhata laid out new methods for algebra and plane trigonometry. He provided solutions for linear and quadratic equations and developed rules for complex series. His calculation for the value of pi as 3.1416 was a monumental achievement, the most accurate approximation anywhere in the world for over 1,000 years. He also created the first tables of scene values, a fundamental tool that would empower astronomers to map the heavens with newfound precision. But his genius wasn't confined to pure mathematics. Aryabhata boldly challenged long-held cosmic beliefs. Centuries before Copernicus and Galileo, he proposed that the Earth spins on its own axis once per day. This elegant theory explained the apparent daily rotation of the stars across the sky. He correctly described solar and lunar eclipses as phenomena caused by shadows cast by the moon and the Earth, moving astronomy away from mythology and towards scientific reasoning. And while he didn't invent the symbol for zero itself, his most profound contribution was creating the system that desperately needed it. Aryabhata perfected a decimal place value system using Sanskrit words for powers of 10. This structure, where a digit's value depends on its position, is impossible to maintain without a way to signify an empty place. He built the magnificent intellectual framework, the decimal house. Now, all that was needed was a key to unlock its final, most powerful room, a formal concept for nothingness, a number called zero. In the intellectual crucibles of ancient India, mathematicians developed a system of breathtaking elegance and efficiency. Numbers were written in a place value system, the very same one we rely on every single day. Unlike the cumbersome collections of symbols used by Romans or Egyptians, the Indian system understood that a digit's power came not just from its shape, but from its position. The same symbol for 2 could mean 220 or 200, all depending on which column it occupied. This was a monumental leap in abstract thought, allowing for calculations of a speed and complexity previously unimaginable. But here's the catch, a profound paradox at the heart of this brilliant system. You simply can't have a place value system without a symbol for nothing. You need a way to signify an empty column. Without it, the entire structure crumbles into ambiguity. For example, how would you write the number 105? Without a symbol for the empty tens column, it would look identical to 15. Imagine an astronomer charting the heavens, or a merchant balancing their accounts. A single misplaced number could lead to disastrous errors. Early scribes tried leaving a blank space, but this was a flimsy solution, prone to misinterpretation. A new idea was desperately needed. The solution came not just from mathematics, but from philosophy. Building on the conceptual framework laid by pioneers like Aryabhata, Indian scholars introduced a symbol for this nothingness. They called it a Sanskrit word meaning void or emptiness. This was a concept deeply woven into the fabric of Indian spiritual thought. The idea of a fertile void, a nothingness that holds the potential for everything. The first physical representation of this profound idea was humble, a simple dot, A. This tiny mark was a revolution in waiting. Over time, this dot evolved, morphing into the small, elegant circle we use today, a perfect visual metaphor for an enclosed, defined emptiness. For centuries, this symbol served its purpose as a placeholder. But it was a 7th century genius, the mathematician and astronomer Brahmagupta, who saw its true potential. In his landmark text, written around the year 628 CE, Brahmagupta took the radical step of treating zero not as an absence, but as a number in its own right. He was the first to formally establish the rules of its operation. He decreed that adding or subtracting zero from a number leaves it unchanged. He defined with absolute clarity that any number multiplied by zero equals zero. These rules, which seem so elementary to us now, were a seismic shift in mathematical understanding. They gave zero its citizenship in the world of numbers. Brahmagupta even dared to investigate the thorny question of division by zero, recognizing it as a unique mathematical state. With Brahmagupta's work, the transformation was complete. The humble placeholder, was now a fully fledged number with its own properties and power. It was no longer just a symbol for what wasn't there, it was a tool for understanding what. This was not just an empty space, it was a real number with its own rules. This simple circle, born from a philosophical void and forged in the mind of a mathematical master, truly changed everything, setting the stage for the modern world. With zero, arithmetic became faster. Merchants could calculate profits and taxes with ease. Astronomers could model the heavens. Engineers could design with precision. When this knowledge traveled west through Arab scholars, the world embraced the Hindu-Arabic numeral system. By the Middle Ages, Europe adopted it, replacing Roman numerals. And from there, mathematics exploded. Algebra, calculus, physics, and economics all relied on zero. Zero didn't just stay on paper. It became the foundation of the binary system, the language of computers. Every app, every website, every video you watch is powered by billions of zeros and ones. Space science too, launch trajectories, satellite orbits, GPS, depend on advanced mathematics that would be impossible without zero. Even global trade, banking, and modern economics run on calculations born from that tiny circle. We stand at the end of a journey that spans millennia, a story that begins not with a bang, but with a quiet, revolutionary thought. Over 1,500 years ago, in the vibrant intellectual heart of ancient India, a seed was planted. That seed was the concept of shunya, nothingness, given a name, a symbol, and a place. It was a philosophical and mathematical leap of staggering genius. We saw a world before it, struggling with clumsy Roman numerals, where simple arithmetic was a monumental task. We journeyed to the great University of Nalanda, a beacon of learning, where minds like Aryabhata didn't just invent, but synthesized and structured knowledge. He gave us a decimal system so elegant, so powerful, that it would change the world. Then came Brahmagupta, who bravely defined the rules of this new number, teaching us how to add, subtract, and multiply with zero, something that had baffled the greatest minds for centuries. From India, this powerful idea traveled along trade routes and through the minds of scholars. It was embraced in Baghdad's House of Wisdom by thinkers like Al-Khwarizmi, whose name gave us the very word algorithm. It journeyed into Europe, carried by merchants and mathematicians like Fibonacci, slowly but surely replacing the inadequate systems of the past. This wasn't just the journey of a number, it was the migration of an entire paradigm, a new way of seeing the universe. Today, the legacy of that seed is all around us, woven into the very fabric of our reality. The next time you unlock your phone, you are using cryptography built on the mathematics of zero. When you send a message, It is encoded in a language of ones and zeros, a binary tongue that forms the foundation of our digital age. Every financial transaction, every stock market trade, every complex economic model relies on the precision that zero provides. From the calculus that sends rockets soaring into the cosmos to the algorithms that power artificial intelligence and map the human genome, the ghost of Shunya is there. It is the silent partner in our greatest scientific achievements and our most mundane daily tasks. It is a testament to the enduring power of human curiosity. It reminds us that the most profound revolutions often begin with a single, elegant idea. While Aryabhata was the genius who helped light the spark, he was part of a grand tradition of Indian scholarship, a collective river of knowledge that flowed for centuries, nourishing the world. So when you look at the marvels of modern civilization, remember that it all began with the courage to represent nothing. Remember the concept of zero. And remember the name of the man who formalized its power for all time, Aryabhata, the father of a mathematical revolution that continues to shape our future. If you found this story fascinating, don't forget to like, share, and subscribe. Which other ancient inventions do you want us to explore? Tell us in the comments below.